This lesson is solving systems of equations by graphing. A group of equations is called a system. So we're going to just be looking at, for this lesson, two equations with two unknowns. So what does it mean to solve a system? It means that you find an ordered pair that is the solution to both of the equations in the system. So number 1 says to determine if the ordered pair negative 3, 2 is a solution to the given system. On this page there are a few typos. So first we're going to scribble out that little S there. And second, in order to do this, we're going to fill in negative 3 everywhere we see an X and then 2 for Y. But this down here says negative 5, so we're going to rewrite that as negative 3. So we need to do it individually. So I'm going to call this top equation, equation 1, and this bottom equation, equation 2. So the first way you can determine whether the ordered pair is a solution to the system is the easiest way. Just plug it in, plug that ordered pair in, and see if it works in both of the equations. So for the first one, it's going to be 2 times negative 3 plus 2 is equal to negative 4. Does it work? Negative 6 plus 2 is negative 4. Yepper doodles, it works. So the first one is okay. Let's see if negative 3, 2 works in the second one. Put negative 3 in for X, 2 in for Y. Yep, that one works too. So yes, negative 3, 2 is a solution to the system. But you can also graph these two lines and see if they meet at the point negative 3, 2. So this is a nice review of graphing. We can graph both of these lines using the slope-intercept form. So for this first line, I'm going to rewrite it as y is equal to negative 2x minus 4. How did I do that? I just brought this 2x guy over to the other side and tucked him in. The slope is negative 2 over 1. The y-intercept is negative 4. So I'm starting here at negative 4. The slope says to go down 2, right 1. Or I can go up 2, left 1. Up 2, left 1. Up 2, left 1. So, and then I can just graph my cute little line. Okay. Make that point bigger because that's where I'm. And then this next one, so like I'm graphing two lines, so I probably should label the lines so I know which is which. So this first line is 2x plus y is equal to negative 4. Good? Now let's do the second line. I'm going to move this guy over and the negative 5 back. So this will become, let me just erase this one right here, you guys. So this guy will become y is equal to x plus 5. So the slope is equal to 1 over 1, and the y-intercept is equal to 5. So here we go. So instead of going up 1 over 1, that would be ridiculous because I'm going away from the point. I can go down 1, left 1. And I'll connect these in blue to the other line. And I'll label it x minus y is equal to negative 5. And you can see that these two lines intersect at the point negative 3, 2. Now, in order to solve a system by graphing, you have to do what we just did. Graph the two lines and see where they meet. So, this first one, y is equal to negative 1/2 x take away 1, is already in slope-intercept form. So that's great. So I'm at negative 1. The slope is negative 1/2, and the y-intercept is -1. So I'm going to go down 1, right 2. Down 1, right 2. Or I can go up 1, left 2. Up 1, left 2. And there's my nice line. I label it. Y is equal to -1/2 x minus 1. Now let's graph the next line in red. This is also beautiful because I'm already in slope-intercept form. The slope is 1/1. The y-intercept is -4. So we start at -4 and we go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Now we'll just draw a line through these points and label the line. Y is equal to x take away 4. And you can see that we actually intersect at the point where x is equal to 2 and y is equal to -2. So we say that the solution to this system is the point 2, -2. And we can check that to make sure that is correct. -1/2 times 2 is -1 minus 1 is -2. 2 take away 4 is -2, and it will check. Again, if we solve this system by graphing, let's take a look at it. This first one, I'm going to solve for y. Y is equal to -2x, take away 1. Again, the slope is -2/1. The y-intercept is -1. So I'm going to go down 2, right 1, down 2, right 1. That's enough. We'll connect them. Label the line. 2x plus y is equal to -1. This guy right here, we can just go for it. Y is equal to -2x minus 4. Well, what do you know? They have the same slope. If you recall, if two lines have the same slope and a different y-intercept, the lines are parallel. So if we're starting at -4, I'm going to go off the map if I go down 2, right 1. So I'm going to go up 2, left 1. And we can see that these lines are parallel if I drew it better. This line is -2x minus 4 is equal to y. And we'll see that they never meet. So what does that mean? There is no solution. And this system is called inconsistent. So they never meet, there's no solution, and the system is called inconsistent. Check, check, check. Next. Let's take a look at this one. Solve the system by graphing. So we got this first line, 2x plus 3y is equal to 6. There's a lot of moving stuff around for this to get it in slope-intercept form. So I'm going to graph it using the intercepts. When x is equal to 0, y is equal to 2. When y is equal to 0, x is equal to 3. So we're going to graph the point 0, 2, and 3, 0, and be done with it. 0, 2, 3, 0, bada bing. I could change it all into slope-intercept form, but this way is a little easier. 2x plus 3y is equal to 6. Now let's do the second line, and I'm just blindly looking at this problem. I am not taking a look anywhere else here. So I'm going to do the same thing. I'm going to graph it using the intercepts. When x is 0, y is 2. When y is 0, x is 3. So I'm going to graph the point 0, 2, and 3, 0. What do you know? It's the same line. Good? So, what is this? They always meet, right? Good. So there are infinitely many solutions. The system is called dependent. This is just the follow-up terminology. If the system of two equations and two unknowns has one solution, the system is called consistent. That means that there's only one solution, they intersect at one point. If the system of two equations and two unknowns has no solution, in other words, the lines are parallel, the solution is called inconsistent. If the system of equations and two unknowns has infinitely many solutions, the system is called dependent. This means that the lines are the same. So we've covered all three cases, and now you can go ahead and do the assignment associated with this lesson. Take care, ask lots of questions. If you have to, go for it. No question should go unanswered.